Now, when we solve quadratic equations to find x, most of the time we have two solutions. Occasionally we won't, and that's if the turning point is actually on the x-axis. So these solutions are known as the roots of the equation, and it's where the graph goes through the x-axis or the x-intercepts. So, for example, if we have something like this, we're going to have two solutions because the first x, so this one here, it has to be 0 to make the whole equation 0. So if we denote that one as 0, so the other x has to be 0 as well, we get 0 times -4, which is 0. Therefore, x equals 0 is one solution. The other option is, of course, making the other x 0. So we need to make this x, give this x a number, so this entire bracket is equal to 0. So to do that, we work out what take 4 has to be 0, so obviously x has to be 4. So we put in 4, 4 take 4 equals 0, so we have 4 times 0 is 0, therefore the other solution is x equals 4. It's the same if we factorise a trinomial, so we have x squared plus 7x plus 12 equal to 0. Now obviously, just looking at that equation, we can't solve it like that. So what we do is we factorise and we do x plus 3 and x plus 4 equal to 0. Now we have to look and think, how can we make this bracket equal to 0? Well, if we make it -3, we're going to have 0. And how do we make this bracket equal to 0? It's going to be -4. So therefore, the two solutions are x equals -3 and x equals -4. It also works if something's in turning point form. So we have x take 3 all squared take 1 equal to 0. Now again, we can't just look at that and see the roots. We actually have to expand this one first. Okay, so we do this, then we actually fully expand it, so we get x squared take 3x take 3x, which is take 6x, plus 9 take 1. Now these two things are the same, so we do x squared take 6x plus 8 equals 0. When we factorise, we're going to have x take 2 and x take 4, because that would make it multiply to 8 and add to -6. So the solutions are x equals 2 and x equals 4 to make this statement true. So non-monic ones are a little bit different. It's still the same principle, so we still have to make each bracket equal to 0. So to do that, we work out what x could be to make this bracket 0. So we just rearrange and solve it, so it becomes x equals 3 over 2 as one solution, and we have 3x take 5 equal to 0. So our second solution will be 5/3. And there are two solutions, and you could put them back into the equation and check if you wish. So now that we know how to find the roots, we can actually add them to our sketches to make them more accurate. Now, you can only add roots to your sketches if it's possible to actually find them, because sometimes the numbers are a bit, like they're not whole numbers, they're irrational numbers, so it could be -0.16666, etc. So you're only looking for the roots on a sketch if you can actually find a whole number or 0.5, etc. So I'm going to do an example now of how we can sketch the whole thing. So we've got x squared plus 10x plus 16. So we need the roots. Now to find the roots of the equation, we factorise it. So it's going to be x plus 2 and x plus 8 to get 16 and 10. Oops, don't need that. So therefore, x has to be -2 and x equals -8. Therefore, the roots are -2, 0 and -8, 0. So we found our roots. That's one thing that can go onto the graph. Obviously, we also have our y-intercept when x is 0. And if we put 0 back into our original equation, we're going to have 0 squared plus 10 times 0, which is obviously 0, and we're left with 16. So the y-intercept is 0, 16. The next thing we need to do is find our line of symmetry. So our line of symmetry, -b over 2a, which is -10 over 2 times 1. So -10 divided by 2 is -5. Our line of symmetry is x equals -5. And the last thing that we find is the turning point by subbing in the line of symmetry. So we sub x equals -5 into the equation. So we get -5 all squared plus 10 lots of -5 plus 16, which equals -9. Our turning point then becomes -5, -9, and it's a minimum. Now remember, it's a minimum because there is no negative number out the front here. Okay, so it's a minimum turning point because it will become the lowest point of the graph, and it will be a graph that looks like this. So now to do a sketch. Again, guys, make sure you use a ruler when you do yours, please. So we need to go down to -9 because that's our turning point, and we need to go up to 16. Remember to label the axes. Okay, so the first thing we can put on our graph is our turning point, and it's at -5, -9. So we're going to go ahead and put a dot at -5, -9. We can also put our roots on. So our roots were -2, 0 and -8, 0. So we can put our 2 dots, one here and one here. We know our y-intercept is 0, 16, so that's going to go up there. And our last point, we've gone 5 this way to get to the y-intercept, so we need to go 5 that way. Our last point will be at -10 and up at 16. Okay, then you draw a line through your curve. Again, guys, remember mine's not going to be as good as what yours could be. So then we label all our points 0, 16 here, -5, -9 as our turning point, -2, 0 as one root, and -8, 0 as the other. Okay, hopefully you have a basic understanding now of what the x-intercepts are. So on Monday, we can do a few more examples and write some notes on the board, and we can start sketching with more accurate graphs. Hope you've had a good weekend.